Alright guys, welcome back to the channel. My name is Oluwashem. Now today, in continuation of our Docker series, we want to look at another interesting Docker command, which is Docker Buildx. Now, in the previous videos, we've seen Docker build, alright, how to build an image from our Docker file. And we've basically just used Docker build, -t and all of that. Now, if I take you back to the image, the Docker file that we've been using, which is the node application. All right, we've been doing Docker, all right, build -t, and then we basically give a name to, all right, the image that we want to build, right? So I can call this node, and then I'll say dot to specify that my Docker file is in this, all right, current working directory. Now, what is Docker Buildx? Okay, we want to understand the difference between the two. So there's Docker build and there's Docker Buildx. So what is, the difference? Now, if you go here and say help, all right, you're going to see a lot of options and a lot of commands, right? Now, if you look at what you have here, under the Docker, all right, we have Docker, and then we have some common commands, all right? So some of the common commands, you can see that there's build as part of the common commands, which basically says that, it is to build an image from a Docker file, which we've been doing even before now. All right. Now, if you scroll down a bit, you have what you call management commands. And here you can see Docker Buildx as one of the management commands. Now, it is not just Docker Buildx, but rather it is Docker Buildx asterisk. Now, asterisk here basically means this Docker Buildx has some other sub commands, all right, that you can also use. Okay, so let's take a look at some of the sub commands. So now if I come here and I say Docker Buildx -help, so let's take a look at the sub commands. Now, look at what you have. Let's start from here. It says the Docker Buildx is extended build capabilities with what you call a build kit. Now, you can say that the Docker Buildx is like an advanced version of the Docker build commands, which means the Docker Buildx has more features and functionality compared to the Docker build that we've been using before now. Is that okay? All right. Now, if you look at the usage, it says Docker Buildx. You put the option and then you follow up with a command, right? Now, let's look at some of the management commands. So you have the image tool, and interestingly, you also have build as part of the sub commands for Docker Buildx. So what really is the difference? Now, I've mentioned one, which is that Docker Buildx comes with some additional features, additional capabilities, and things like that. Okay. Now, let me practically explain to you the difference between the Docker Buildx and Docker build. Now, when you have a system, your system, depending on, the manufacturer, right? For example, if you're buying maybe an HP laptop or a Dell laptop, now these systems often have different architectures, all right? For example, you can buy a system that comes with an Intel, all right, processor, right? The architecture is maybe Intel, all right, and then it comes with maybe x86 processor or x64 processor and things like that. And then you can buy another system that comes with maybe AMD, and then it has maybe ARM processor or AMD processor and things like that. Okay. Now, your operating system as well comes with, different architecture. You can have an operating system that is x86. You can have an operating system that is x64. All right. There are different platforms. And for some of us, if you've used Windows, if you've used maybe Windows 7, Windows XP and all of that, you will realize that if you have an application, for example, if you want to install Microsoft Office, there's the x86. In those days, there's x86 version and there's x64 version. So if your operating system is x86, you can't install an x64 application on that operating system. It's not going to work. All right. And of course, it's vice versa. So if you have an application that is x64, you cannot install that application on x86 operating system. All right. Now, that is one of the difference between the Buildx and build. Now, if you go here to Docker Hub, let's take a look at something. If I come here to Docker Hub and let's search for an image. All right. Let's just say we're looking for a Docker image. Okay. That's what we're looking for. Now I'm going to click on this image. Any image actually. So I'm going to go to tags. Now look at the tags that you have here. Now under this OS and architecture, look at it. There are 4 types of OS and architecture here. So there's the AMD 64, there's the ARM version 6, there's ARM version 7, and there's ARM 64 version 8. All right. So which means this Docker image that I have here can run on these different platforms, which means peradventure, if I'm running Docker on maybe an ARM, version 6 operating system, I don't have a problem. There's an image that is fit for that. All right. If I'm running an AMD 64 system, I mean, most of the Linux system that we use, they're actually AMD 64. There's no problem with that. And if my architecture is ARM version 7, I don't have a problem because this image clearly has, an image that is suitable for that particular OS architecture. Is that okay? Now, the same thing also happens when you go on AWS, for example. If you go on AWS and you want to launch an instance and all of that, I mean, when you select your operating system, now if you scroll down, you have what you call architecture. Now, under here, you can run an x86 64-bit architecture or an ARM 64-bit, architecture. Okay. And of course, if I click on Windows, for example, that will have its own architecture as well, right? So if I come here, I mean, that comes basically with just 64-bit x86 architecture. So which means your Windows cannot run on maybe AMD or ARM architecture. Do you see the difference now? But if I click on, let's click on Mac. Let's see the architecture that the Mac uses, right? So if you click on Mac, that also supports the it supports the 64-bit Mac, and then there's also the ARM version also. So depending on, the instance you're using and all of that, okay? So now, what I want to show you is this. Now, how do we generate these different architectures? I mean, when you're building an image, how do you say, oh, I'm building a Docker image, but I want my Docker image to be this architecture. I'm building a Docker image, I want my Docker image to be this particular architecture. Or you can even say, I want to build a Docker image that has 3 different architectures so that anybody that is pulling that architecture, regardless of the OS or the system architecture they are using, they are able to run my image. Is that okay? So how do we do this? Now, that is where, your Docker Buildx, comes into the picture. All right, because with the Docker build that we have, we can only build a single architecture. And that single architecture that we can build, we don't even have an option to decide which one do we want to build. Because with Docker Build will basically just use the system architecture where that build is actually running. So which means if you're running Docker Build and your system is x86, Docker Build is basically going to build an image for you that is x86. If you're running Docker Build on a system that is AMD 64, Docker Build is only going to build an image for you that is AMD 64, because that is the architecture of the system that your Docker Build is running on. But with Docker Buildx, we can do much more. We can build images for different architecture. And that is exactly the importance of Docker Buildx. I mean, that's one of the importance, right? Because, I mean, it can be used for different things. Now, another thing I also want us to look at is that now, by default, when you build an image with Docker, right, it creates what you call a cache. So that the next time you're building that image, I mean, if there are layers that have not changed, it basically just pulls them from the cache, and that will speed up your build at the end of the day. Right? Now with Docker Buildx, you can even do much more, which means you can actually have a registry cache, which means you build an image, you push that image into maybe a Docker Hub registry or an ECR registry. The next time you are building or rebuilding an image from that Docker file, you can actually fetch the previous image that you have built, as a cache that the new image you want to build can actually leverage. So that if there are layers that are already available, in the previous image that you have built, the new image you're trying to build does not need to recreate those layers again. It basically just picks it from the previous, image. So that is one of the importance of Docker Buildx that we're going to see. So I've mentioned 2 things. Number one, you can use Docker Buildx to build for different platforms like what we see here. So there's AMD 64, there's ARM version 7, and there's also ARM 64 version 8. So we can use Docker Buildx to build these different architectures and push it into a registry so that if anybody within our organization, if the platform they are using is not AMD 64, perhaps they are building on ARM, I mean, they can leverage that, particular opportunity or feature of Docker Buildx and have an image that is of that particular platform, and there'll be no issue at the end of the day. All right, so that is what we want to look at in today's tutorial. So now let's try to build this same image, this same file rather, into an image using the buildx features. Okay, now I'm going to be leveraging the documentation in order to do that, so that we can understand how to also leverage the documentation for things like this. Now, one thing I will also need to mention is that you must have a Docker Hub account already. Now, if you don't have a Docker Hub account, Docker Hub it's an image registry where you can actually push your Docker images to if you're not using ECR, for example, or any of the cloud platform image registry. Is that okay? So you can, let me just open a new tab here, and you can come here to Docker Hub, and you can actually just, click on sign up, and then you can sign up. You can put your email, your username, and then your password. And of course, you can also sign up with your Google account or your GitHub account as well. And that would, give you access to the GitHub repo. And of course, if you have already signed up, you can also, you can take a look at how it looks like. So let me just log in into my own so that I can show you what it looks like, because we're going to be pushing into the Docker Hub registry. So this is my own, backend, my Docker Hub registry. So you can create a new repository here, and all the repositories that you create here will actually be public because it's a free version that we're using. So every repository we create is actually going to be public, but you can only have one private repository, right? Can only have one private repository. And that also means that every repository that you create here, it also means that the images can be, they are searchable on Docker Hub, right? Because they are public images, which means anybody can actually download those images. Anybody can actually, make use of those images because, they are public images. So people do not need to authenticate in order to pull the public images, including the one that you push into Docker Hub. Is that okay? All right, so we're going to be doing this. And of course, if you want to learn how to authenticate with your Docker Hub account as well, you can also open up your terminal. That is assuming you have, Docker installed already. So whether on your EC2 instance or on a Windows machine, if you have Docker installed already, you can just basically say Docker login, and then you authenticate. But of course, I've authenticated already, so it's going to use my existing credentials. But if you're trying to authenticate for the very first time, you can just say Docker login -u, and then you're passing your username. For example, my own username is this. All right, so that's my username. And then if I press enter, it's going to prompt me to put in my password. And then I will be able to, log in into my Docker Hub. Now, the purpose of that is when I want to push into that registry, I need to authenticate with the registry to push to the registry. So I have to log in before I can push to the registry. So whether my image is going to be public or private, before you can push to any registry, you have to authenticate with that registry before you can actually push to the registry. Is that okay? So I needed to show you this because we're going to be leveraging all of that as we go on. All right, so let's take a look at how we can use the buildx. So this file rather, I keep calling it image. This file rather is what we're going to be using, right? This is the file we want to build into, an image. We've built this file to into an image multiple times, but today we want to use Docker Buildx, to do that. So I'm going to say Docker build, buildx, and then build. So that's the command, right? Docker Buildx and build. Now, a few things that we want to do, we want to actually, create a cache, right, for this particular, image. So we're going to be using the -cache2 option, because if you come here to the documentation, you can actually see a list of options that you can actually use with that command. So, and one of the options you can use is the, cache option. So there's cache from and there's cache2. So we're going to be using the cache2 basically to include the cache inside of the image, so that the next time we are pulling that image, we can leverage the cache that is already available inside of that image to speed up, the build the next time we're trying to build an image from the very same file. All right. So we're going to be using the cache2. So, and then we have different options here. So you can have cache2 the registry, which basically means you want to create a cache, into that image, and at the same time you're pushing that into the registry. Okay. But of course, we're going to be using the cache inline, because the purpose of the cache inline is that it writes the cache metadata inside of the image, itself, which means your cache is contained inside of the image, as a metadata. Okay. So that the next time you push or the next time you pull that image, image rather, it's basically just going to extract that metadata and leverage that for the new image you're trying to build for the same Docker file. Is that okay? So that's what we're going to be doing. So if you scroll down, you have examples here. So I'm just going to copy this example that we have. All right, and then I'm going to pull that here. Okay, so it's going to be cached. For the type is going to be inline. And the next thing we want to do also is that we want to build for not just, all right, the AMD64, which is the Linux that we're using, all right, for our Docker desktop, but we also want to build for another platform like I showed us, right? So let's come here and look at this other option. So here you have the option of platform. So you can build for AMD64, you can build for ARM64, and multiple platforms actually. All right. So I'm going to copy this flag. Okay. So let's just take this two. Okay, and let's put it here. So basically what I'm trying to tell Docker is that I'm not only building for the architecture that I am using at the moment, but I also want to build for another architecture. So which means it's going to produce a single image for me that has different architectures. All right, so it's going to be a single image, but of course it's going to have different architecture, like we saw on Docker Hub, right? When we looked at the Docker image and some other ones that we looked at, we saw that we had different OS architecture. So that is exactly what we're also seeing here. So it's not as if we're going to have two different images, right? But it's going to be one image, but of course it's going to be of different architecture. It's going to be like bundled together. Okay, so by the time you're pulling it from the Docker Hub, it is going to basically pull it for your own architecture. So if your own architecture is available as part of the one that was pushed to Docker Hub, it's basically going to pull that or a particular architecture for you. All right. So now I'm going to say -t. So the -t here basically is to tag the image. So I'm going to be tagging the image with my Docker Hub username, because that will make it easy for me to push, all right, to Docker Hub later without having to retag, all right, the image. So I'm going to use that. So I'm going to say Oluwaseun A. All right, that's my name. All right, my Docker Hub username, and then I'm going to create a repo for this particular image. So the name of the repo is going to be node. All right, and then let's just give it version 1. Okay, as the version, and then I'm going to say dots. Right now, one thing I need to mention here is that when you're using, all right, the platform option, which is you're building for different platforms, sometimes it takes a longer time, right, compared to when you're building just, all right, for the architecture that you're running the build on. Okay, so we need to take that, all right, we need to understand that. Okay, it takes a longer time, right? Depending on the Docker file, depending on how large your Docker file is, depending on the dependencies you're trying to, build inside of the Docker file and the image and all of that, right? But of course, it does take a significant amount of time when you're doing a multi-platform build, all right? And then of course, you have to also take into account the system resources that you have, the memory, the CPU that you have, because it's going to consume quite a lot of that, all right, as well. So I just need to tell you this, so that in case you're trying to do this, all right, on your own, you already have that idea that this is going to take time and it's going to need a lot more resources, all right, which your system may not, all right, have at the moment. Okay. All right. So let's press enter and let's see what happens. Now, look at the error that I got. So it told me here, all right, what I'm seeing here says multi-platform build is not supported for the Docker driver. Now, one thing I need to mention here also is that how do I put it? Now, when you're trying to build, all right, for different platforms, right, the native Docker driver does not support that out of the box. All right, so you need to find or you need to download what you call a containerd image store. Now, for Docker desktop, you can actually enable that within your Docker desktop. But if you're running on EC2 instance, Ubuntu, Amazon Linux, and all that, you may have to, all right, search the documentation more, which at the moment, I really have not had, any reason to do that. Okay. But of course, if you're running a pipeline, maybe you're running a GitLab pipeline and all of that, you won't have any issues at all running the dockerbuildx, because automatically it will create, all right, make available what it needs to build your image and do all of that. I've tested that before in my own work, in my own project, right? Within my GitLab CICD pipeline, right? But then when you're building like this locally on your system, on your machine, all right, you have to turn on some extra feature in order for this particular command to work. Okay. So we're going to go to our Docker desktop. I'm going to go to settings. And if you scroll down, there's this option that says use containerd for pulling and for storing image. And if you look at the description here, it says it supports multi-platform images. All right, so I'm going to enable that. It's going to give me some options, blah, blah, blah. I'm going to say enable, and then I will apply and restart, all right, my Docker desktop. Okay, so I'm just going to wait for that to restart. That was quick. So I'm going to, minimize that, and then I'm going to run that same thing, all right, again. So like I said, this takes a significant amount of times, all right, depending on the Docker file that you're trying to build an image from and other things, okay? So let's give it a try now, and let's see how long this is going to take. So I'm going to pause my screen at this point, and when everything is done, I'm going to resume back, and then we continue, all right, from there. All right, guys, now let's take a look at how long it took for this particular image, all right, to be built. Okay, now if you look at this, the output of the Docker Buildx here, you'll realize that we have for AMD64 and we have for ARM64, right? Now, if I come here to my Docker desktop, okay, and I come to build, right? This is the build that we just ran, okay? It was just 5 minutes ago. Now, this build took 3 minutes, 44 seconds, right? And if I come here to images, I can see the image right here. And if you look at the image size is basically 331. All right. Now, I told us earlier, I said it is not as if you're going to have like 2 images, okay? Maybe one image for ARM, another image for AMD. It's basically just going to be one image, right? And then anybody that is pulling, it is going to basically, they are going to be pulling just for the architecture, okay, on the, the architecture of their system where they are pulling the image on, right? But of course, if you look at the size here, you would realize that this size is basically more like combining the size of 2 images together. Is that okay? So that is why you have the size. And because normally this node image, we've built it before, it shouldn't be more than 183 MB, right? But of course, we have 2 images in one. And that is why you have the size like this. Okay? So what I'm going to do now is to push this, all right, to our Docker desktop, and then we can also visualize it and see, all right, some things on the Docker on the Docker Hub rather as well. So I'm going to say Docker, all right, images first. So let's get the name of the image. So the image is this, all right, and this is the image that we are pushing. Okay, so I'm going to do here. I'm going to say Docker push. So the name of the image I want to push is this. All right, and then node column v1. So that's the image I want to push. Remember, I'm pushing this to my Docker Hub, and I've done my Docker login already. So I'm going to press enter. So that's going to push to my Docker Hub. Now, the push will also take some time because, you're pushing 2 images, but of course, it's been, it's more like it's zipped together, right? So you're pushing everything as one image. Okay, so at the end of the day, when somebody is pulling that image, they're only going to pull for their own architecture. They're not going to be pulling everything. All right, but the way Docker has done it is such that, the whole image will be compressed together, all right, as just a single image. But of course, when you now get to Docker Hub, you can now see the different architectures. So by the time you are pulling for your own architecture and not all the architectures. Is that okay? So let's wait for this, push to complete, and then we'll come back when the push is done. All right, there you go. So the push has actually completed. All right, so now if I come here to my Docker desktop, and I come to images, right, I can see Hub right here. So if I click on Hub, I can see the new image that I just pushed, right? You can look at that, right? That was just 17 seconds ago, okay? And of course, you can see the version 1. And if you look at the OS, we really don't see too much information here. But what we can do is to go to the Docker Hub, all right? So I'm going to come here. I'm going to just open Docker Hub, right? Docker Hub. And I'm going to come here and I'm going to search for that image publicly. Now remember, so I'm going to click on Explore. All right. Remember that I told you that any image you push into Docker Hub, as far as that image is a public image, it is searchable, which means anybody can actually pull that image and make use of it. Okay. So the image I'm looking for is this. All right. A/node. Okay. So that's the image I'm looking for. And right here, you can see that image. And it says what? It was updated a minute ago, right? And then I'll click here. All right. Now, if I click on tags, you're going to see what I'm talking about. So look at it here. So look at the tag, right? So the tag is what? Linux AMD64 and what? Linux ARM64. Now look at the sizes, the compressed size. So this is 60 and this is 59. So that size we saw locally is just basically 2 images in one. And that is basically what we saw. Okay, so now if you go on Docker Hub the next time and then you see something like OS Arc, right, and you see different architectures, you have an understanding now how they got that, right, how that was built. That was built using what? Docker Buildx. And that's why you can have multi-platform, all right, Docker images. Is that okay? And the last thing that I want to show you is how to speed up, all right, your build. Now, the last build that we did actually took, a significant amount of time. Right, if you come to build history, it took us about 3 minutes. Right, there are some builds that can take you like 1 hour, 40 something minutes, and all of that. But this one took us 3 minutes. But we can actually speed up, all right, that build. Okay, so how do we speed it up? Now I'm going to call up the previous command, which is this one. Okay, that you can see right here. All right, I'm going to call it up, and I'm going to use the catch from. Okay, to basically speed up that image. And I'm going to be using an extra flag, which basically means I want to build and I want to push at the same time. Okay, that's what I want to do. Now, if you go back to the documentation, you would find here that there's what you call a catch from. So which means we have done catch to, right? Now we want to build another image from our file, but of course we want to leverage the cache, all right, that we have pushed with the previous image, so that this time around, instead of taking 3 minutes, the build should take us maybe 10 seconds or 20 seconds. Okay, that's exactly what we want to achieve. So I'm going to copy this one because the image that I want to leverage the cache has actually been pushed into the registry. All right, so the cache is going to be coming from where? From the registry. All right, so I'm going to be using that. So copy that, and then I'm going to be dropping that here. All right, remember to remove the dot. So the registry is going to be, all right, so the registry is going to be my Docker Hub registry. So the name there, then the node column v1. That's the name of the image that we have embedded the cache inside of. Okay, so we are pulling, all right, that image to leverage, okay, all of the things that have been bundled with it, so that instead of the new build taking us 3 minutes, we want to look at it that it should take us maybe 20 seconds or 1 minute even, right? So that's what we want to do. And of course, we're still going to be building for the same, all right, platforms, AMD64 and ARM64, but I'm going to be changing this one because it's going to be version 2 now. So let's call it version 2 so that we can distinguish between the two of them. Is that okay? And I'm going to be adding an extra stuff, which is push right here. So with your Docker Buildx, you can build and push at the same time. All right? That is the beauty of the Docker Buildx. So I can build and at the same time I can push. So which means the moment the build is done, immediately it pushes. So I don't need to do Docker build, Docker push separately. I can actually do the thing, all right, together, right, as one command. So build and push at the same time. So let's see what this would do for us. All right, let's see if we got it right. And then let's see that. All right. So let's wait and see. It shouldn't take too much time. So let's see how much time this is going to take us. Okay. Now you will agree with me that that was very fast, right? So now let's take a look at what happened. Now here, it basically tells us, it says importing cache manifest from this guy. All right. And it says inferred cache manifest type blah 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 from this, and then of course that cache was what was extracted, and then that was what was used to build the image. So you can see that here it says cache. The layers were already available, so you didn't have to, all right, you didn't have to build those layers again. Okay, it basically leveraged the cache, and that speed up, all right, things. And of course, because of the push option that was specified, you can see that immediately it pushed into, all right, our registry. So now if I go back to my Docker build, look at that. Something that took us 3 minutes earlier took us how many seconds? Just 17 seconds. Okay, that is the purpose of the cache, all right, or caching, as you may want to call it. Right? That's the purpose. So now it took me just 17 seconds to build the same image or the same file that took us 3 minutes, but now it took us just 17, all right, seconds. And now if I go back to my Docker Hub, all right, and I refresh right here, I should be able to see, all right, another tag, right? So I can see version 2 right here, all right, and I can see that that was pulled maybe 7 minutes ago. I pulled it, and then you can see that I was also pulled 2 minutes ago. So you can see the different versions. So the next time you go on Docker Hub and you see things like this, now you have an idea, all right, how they got, all of that, right? You can see the OS architecture, how they got the OS architecture, how the tag came about, and all of that. So thank you so much, and I'll see you on the next one.